Hello and welcome back. We're going to have a look now at some kind of real world or some common applications for compound interest. Let's start by having a look at strip bonds. Now, in your book in the previous pages before you get to strip bonds, they do talk about Canada savings bonds. I'm not going to worry about those too much. Instead, I just want to start with strip bonds. So let's have a look. A typical bond is an investment that pays an investor two things: regular interest payments, we often call those coupons, so regular payments over time, and a lump sum, one single big value, a lump sum redemption at the end of the bond term or when it's all done. Well, a strip bond is where we take the second portion of the bond, just the lump sum amount, and sell that as an investment. So the regular interest payments aren't involved anymore. They've been stripped away. So to solve this type of problem, then really it just becomes a simple application of our present value formula, where we take the lump sum and bring it back in time to the date of the purchase to find out the fair market value or the purchase price for that strip bond. Let's have a look at an example. We have a $1,000 face value strip bond. It has 7 years left until maturity. If the going rate or the market rate of return is 2.6% compounded semi-annually, that's a J2. What's the price or what's the fair market value for that bond? Well, let's start by writing down what we've got. The face value, which is what we're going to get in the future, so I'll use future values, $1,000. It has 7 years left to maturity, and in this question we're compounding twice a year, so that's 14 periods. Little I is going to be 0.026 over 2. I got the 2 from over here, didn't I? And that's 0.013, and I want to find the price or the present value for this bond. You can think of a picture if you like. Here we are. Today we've got 7 years. We're going to get $1,000 in the future. Let's bring it back to today and see what we would pay. So that's what's going on with this one. So the fair market value or the price is going to be $1,000 brought back at 1.3% every 6 months for 14 periods, and that works out to be $834.58. And if you've forgotten, a promissory note is really kind of like an IOU. It's a contract between a couple of people, someone who borrowed some money and someone who lent it to them. And it states how much was borrowed, how long until it's going to be paid back, and then what kind of interest rate we're going to use to work out how much will be paid back. It doesn't actually say what will be paid back in terms of dollars, but it does give you the starting amount and the rate, so we could work that out ourselves. And then the interesting thing for us is typically when we're working with them, we look at a situation where the person who is holding the note doesn't wait until the end, but they sell it to a third party sometime before maturity, and we want to work out that sale price. So just like before, we typically have two steps that we're dealing with when we're dealing with a promissory note. First, we want to calculate the maturity value, and then we want to discount that back to the date of the sale. If I were to draw a timeline for sort of a generic promissory note, we've got some money that was borrowed. Step one would be to find out what the maturity amount is. And then step two would be to take that amount back to the date of sale to work out the price. Now for maturity, for step one, we can use the future value formula that we've been working with. And when we get to step two, we're going to use the present value formula to work backwards. Now, a couple of important things. The N's and the I's will change typically between the two, and also the units may change. You may find that originally the rate goes forward could be a monthly rate, for example, but when we work backwards, we might switch to a quarterly rate. So we just have to be a little bit careful to really think that through and make sure we worked out I and N correctly each time. If we think about someone who's bought, or has borrowed some money, they're still going to pay back that money at the end. So they're not really affected.
but the person who lent them the money wanted out early at this point in time. So they will now get this new amount, the price, at an earlier date. And the person who paid that price, you can almost imagine someone here who's paid for it, what are they getting? Well, they don't really care about the past. What they care about is what are they going to receive. So in finance, people tend to look forward to what they're going to receive, and that would be the maturity amount that we calculated in step one. That's why we have to do promissory notes that way. We have to get the maturity amount first, because that's what the person's really buying the right to collect, and then we can bring that back. Let's have a look at an example. Joe borrowed $2,000 from Rob and agreed to repay the loan in 3 years with an interest rate calculated at 6% compounded semi-annually. That's what the J2 means. 1 year after the loan date, Rob sold the contract to Julie. When we calculate the price that Julie paid, if she wanted a return of 4.8%, she doesn't actually want to earn as much. So we know there's going to be some differences here between them. We've got to be a little bit careful then. We've got to work out maturity first and then bring it back. So let's have a look at how this one kind of plays out. Let's draw a timeline and start to put everything on there. So the original loan was $2,000. He's going to get paid back in 3 years with interest at 6%. I'll draw an arrow all the way out to the 3-year mark. And I want to work out that maturity amount. Well, let's see. Can we work out N and I? I have 3 years compounding twice per year. So 3 years twice per year gives me 6 periods. So that's what we want there. And the interest rate per period is 6% divided by 2, or 3% every 6 months. So there's the formula for maturity value. We put the values in there that we've worked out. We find out that the maturity value of this note is $2,388.10. That's great. Step one done. And if the note was never sold, that would be the end of the question, really. That's just what would Joe would pay back to Rob at the end of the whole deal. But the note was sold, so we have a step two now. We want to bring the value of that note, the maturity value, back to the date of sale, which is at the 1 year mark. Okay. That's where we want to work out the price. We got a new N and a new I now. Now things are monthly in this case. If we look at our rate here, it's a monthly rate. So we're going back 2 years times 12 times a year. That's 24 periods. And the rate per period, 0.004 or 0.4%. Now I can work out the price. That's my step two. I'm going to use a present value formula for that. Now notice the value here, that's the value that we calculated. That's a maturity. That's what the person is expecting to receive, what Julie will receive when she waits around till the end. What would she be willing to pay for that if she wanted to earn her 4%? $2,169.92. All right, time to try one out here for you. See how you're doing with these. We got a 5-year, $1,000 promissory note bearing interest at 8% compounded quarterly. And it was sold 2 years before maturity to yield the buyer 9% compounded monthly. See if you can work out the sale price. I'd suggest you hit pause again right now. Take a few minutes, pull out a sheet of paper and try this one out. And when you're ready, come on back, press play again, and I'll go through it with you. All right, let's have a look. Start by just drawing a little timeline here. It's a 5-year note, so I'll put 5 years down here. $1,000, bearing interest, so that means I have to add an arrow in here to represent the interest. At 8% compounded quarterly, so I is going to be 0.02, and N is going to be 20. I'm going 5 years, 4 times a year. Let's just work out that maturity amount now for this note. That'll be the 1,000 carried forward for 20 periods. And you end up with $1,485.95. That's the maturity value for this note. That was sold 2 years before maturity. You gotta be careful there, not at the 2-year mark, but 2 years before 5, which would be at the 3-year mark, to yield the buyer 9%. Can we work out the price at that point? Well, little I here, 0.0075, and I got that by taking the 9% divided by 12. N is going to be 24 because that's a 2-year span, compounding monthly. Let's work out the price. I'll take the full maturity value because that's what the person will receive when they buy the note, or what they expect to receive when they purchase a note, and bring that back for 2 years. And that works out to be $1,242 exactly. That's how much the note would be sold for at the 3-year mark. That's it for promissory notes. I'd like you to go back to the textbook and try them out. You see they work kind of the same way they worked before. It's just we've updated our formulas, so this is a great chance to practice that. Give you a little more practice with the compound interest formulas and working out I and N and all of that sort of thing. Once you've worked through the text, you'll be ready to move on and tackle the next section.
Let's have a look at one final application in this section, and that's inflation. You may already feel like you've got a sense of how this is going to work. Basically, we can use what we know about compound interest to look at how values change over time. So if we think the annual rate of inflation be constant over the next 20 years, how much will a hamburger cost? Well, let's assume they cost $9 now, and the inflation rate will be 2% each year for each of the next 20 years. So that's 2% over on itself every year. Well, we've got currently a present value of $9. That's the current price of a hamburger. The inflation rate is 2% compounded annually. That's what we'll do with inflation. And we've got 20 periods or 20 years to go. What's going to be the price of this burger in the future? Well, future value is present value times 1 plus I to the power of n, or in this case 9, times 1.02 to the power of 20. And that works out to be $13.37. So a hamburger will cost a little more in 20 years than it does today. Let's have a look here. We've got tuition at West Coast College at $200 per course, but that was 18 years ago. Today they're charging $335 per course. Assuming that the rate of inflation was 2%, has the tuition rate changed much in terms of real dollars? And what I mean by that is if we take the $200 forward, will it be $335, or will it be the current rate be a bargain, or perhaps maybe more than we expect? So let's have a look at how we could do this. I'm just going to say, look, the present value here is the original $200. We've got 18 years on the go and an annual rate of 2%. Can I work out what tuition should be today if it had only gone up by inflation? Sure, that's going to be 200 times 1.02 to the power of 18, which works out to be $285.65. So that's what tuition should be, but unfortunately, it's now $335. So that's the bad news here. Tuition has gone up by more than the inflation rate, it appears. In terms of real dollars, the student should only pay $285 now, but they're really paying $335. It's not as good a deal for students today as it used to be. That's it for this section. Go through and do lots of practicing. Get really comfortable with all the formulas. I hope you're starting to feel that way now as well. And I'll see you again next time.